Sorry ya, aku ora poso ya.
Santai-santai, Pak.
Pecah-pecah dulu bro. Ya.
My name is Petrus Tejabsoro, as the Managing Director of PT Yogya Presisi Teknika Tama Industry. Our company focuses on manufacturing industry to meet local and global customer needs such as precision part, plastic injection mold, mold making, jig and fixture. Our customers from automotive industry, electronic, food and beverage, energy, medical devices and aviation industry. Our mission is grow together with all members of company, customer, government and society to be a competitive company. For more than 20 years, we consistently to level up our competency with develop human capital and technology, collaborate with vocational education and government. That is why we recruit the best talent and develop creativity. We have 5 divisions. Those are, first is precision part. From small, medium and high volume we supply to customer any kind of industry. Our precise machines, measuring instrument and accurate strategy make us have capability to produce your product with high quality and on-time delivery. The second is tool making. We supply plastic injection mold and aluminum die casting with high technology, high quality and competitive price. The quality of your product is supported by more than 20 years experience by design, reliable software, high-tech machinery such as 5-axis CNC milling, CMM for final check and high standard of polishing. The third is plastic injection. With different special technique including inserting mold, multi-component injection molding, we guarantee extra added value for your product. We transfer your concept to a fully elaborate technical design, ready for production by custom. We are also supported by 27 injection machine from 25 ton until 550 tons capacity. In one of those machines, there is a new technology with double color injection. We mean of plastic injection technique, we produce all kind of object with a large variety of plastic. The fourth, training center. To develop soft skill and hard skill to student and our employee, we have professional training instructor with various experience in their field who are capable to implementing and interpreting their ability to the participants. The instructor provided with the most recent knowledge in the development of information technology. And the fifth is information technology. To support Indonesia Revolution 4.0 in manufacturing, to more competitive, to increase productivity by online data, we can trace information faster and more easy to make key performance indicator in every division. So we can improve our services and work more efficient. To strengthen Indonesia industrial resilience through ecosystem development activity by collaboration all stakeholders, YPTI has collaboration with 50 education institutes, including reputable universities, vocational high school, and polytechnic. We build partnership not only with big company locally and international, but also with industry association as well as supply chains industry. We also have partnership with government to develop industrial ecosystem. We even work closely with small and medium enterprises because we would like to share and grow together. In the Industry 4.0 era, our company is required to be able to adopt and adapt with technology. In our company, the implementation of Industry 4.0 for sure needs to benefit to the companies such as improving connectivity, traceability, efficiency, and productivity. During COVID-19 pandemic, we have collaborated with researchers from Higher Education Institute to develop ventilator to support government program in solving the problem related in limited medical device. We proudly joined the Hannover Messe exhibition 2021. Joining the exhibition, we are able to introduce our product, the ventilator R03 back valve mask to ventilator system and ventilator V01 ICU. Further explanation about the ventilator produced will be delivered by Mr. Adhika Widya Prakarga. Enjoy, Mr. Adhika, please.
Thank you, Mr. Petrus. Hi, everybody. My name is Adhika, and I am from the University of Gadjah Mada. We have been collaborating with YTTI in University for quite some time now to develop medical devices. Among those are these two here. Now, so it began around last year. So we were concerned that we were hit by the COVID outbreak pretty hard, and we were concerned of the shortage of medical devices, of which ventilators were a large part of that. And so we intended then to develop an ecosystem that allows the development of medical devices from the upstream to downstream. So we collaborated also with the public hospital here in Yogyakarta, Indonesia. We collaborated with Sarjito Hospital, and we also collaborated with several startups, including and also with another company, Spice Up, and several others. So this is a very expensive undertaking, and we involved a lot of collaborations here, including 3 ministries: the Ministry of Research, the Ministry of Health, and so here we have these 2 devices. Here we have the 2 devices. This first one here is the R3. The R3 is a valve, bag valve mask conversion kit for an ambu bag or a bag valve mask to a ventilator. So here we can see. That this has an ambu bag here, and it's very simple. You just insert this bag here, and then attach the sensors, and you have a functional ventilator. Okay? And so here we have several modes. We have a continuous mandatory ventilation mode, and also we have a SIMV, or synchronized intermittent mandatory ventilation, and we also have a spontaneous mode and also an assist control mode. So we can set these modes. We can set, as with commercial ventilators, we set the tidal volume, respiration rate, the inspiration-expiration ratio, the plateau, and such. So here we'll set it, and then we can see how it works. And so I'm running assist control. An assist control mode, and here we have the top graph is the pressure, and the bottom graph is the flow. So here we can see the flow and the pressure that are measured by during the breath given. And we are setting it here at 360 milliliters of tidal volume. So despite its simplicity, so it's although it's simple, it's tough and sturdy, and it's very portable. Really reliable, and you can have it has a pressure trigger mode, so it has a pressure trigger, so you can have these. It can adjust according to patient breath, spontaneous breath detection, and such. So despite it being only a bag valve mask conversion, it can detect patient breath and such, and adjust and such. So we have the oxygen sensors here, and the inspiration and the expiration valves here. So this is our portable device. We envision it to be able to be used in rural areas and such, and also to be used in emergency rooms where employment of full ICU ventilator is not possible. So this is our first device, the R3 Venindo. And our second device here is the Venindo V01. This is the ICU ventilator we have developed, and fully functional ventilator, and it has 4 categories of modes. It has volume control modes, pressure control modes, spontaneous modes, and also intelligent modes. And for the volume controlled and pressure controlled modes, you have a continuous mandatory ventilation, you have synchronized intermittent mandatory ventilation, and also assist control ventilation for both pressure and volume control. And here you can see, let's say we are choosing synchronized intermittent ventilation, and we can set the parameters. So we can set, let's say we're setting the tidal volume to be 300. Let's say 300. Oh, sorry. Yeah, it's 300. It's 310. No problem. So, and then we set the PEEP pressure, 5 centimeters H2O, and we can set the respiratory rate and such, and pressure support. And say that's one we want. And we can also set the flow pattern type. Let's say I want a trapezoid type, and the flow trigger and or pressure trigger. And so here we can start the ventilation, and you have a pressure wave on top, a flow diagram in the middle, and a volume diagram below. You can set the alarms with this here, and you can also check the adjust in real time here, or you can set a more detailed change of parameters in real time here. So, and of course, we have a patient detection, patient breath detection. So if I inhale, if the patient inhales, you have an indicator whether or not when the pressure is inhaled, the breath is inhaled. We can check the alarms with the green button here if there are any alarms. So here you can see. Okay, and you have a patient trigger. Can we try other modes? Let's try a pressure controlled mode. We can try the pressure controlled assist control ventilation. So let's press this one, and then we can choose. Let's say I want a 20 centimeter H2O pressure, and I want a respiratory rate of, let's say, 12. And so we can start it, and we can see that it changes to a pressure control mode. So it fixes at 20 centimeters H2O, and again we have pressure detection. We set the pressure support at 20, so it has about the same height. So we intend also to implement IoT, so it'll be able to monitor the functions via device. So you can use an external device to monitor the functions and also the graphs and such. So this is our ICU ventilator, the V01 Venindo. Now, the ventilators here, so we developed these ventilators, and they are currently undergoing clinical trials. And we have the R03 has been used for several patients in the operating room, and for the ICU ventilator, we have used it in the intensive care unit. So these have been they are currently under clinical trials. And so we hope that we can finish these clinical trials within the year and have both evaluated, and hopefully we can launch within the year. And if we are also open to proposals for research or of development of components for medical devices or medical devices. So if anybody was interested in collaborating for both research or manufacture or for supply chain development, we are very open to advice and suggestions. Thank you very much. Oh, I have a question here. Is there the safety devices? Okay, so both devices have complied for ISO and for the electrical safety standards. For intensive care devices and for electrical safety standards. So safety devices, we have, of course, we have a battery. Battery for if any other, so the electricity is down or such. This battery can last for a total of six hours. This is around 3 for this one. And also we have, of course, we have a safety valves which we developed ourselves to avoid barotrauma. And we have also have electrical safeties for volume and also for pressure. And of course we have alarms that can be set, and also we have protection from accidental in contact for the power button and such. Yeah, this device also has safeties for pressure, and also we have the battery, as I told before, and also has alarms that are fully functional. Okay. And we also have another question. Okay, the next improvement. So, as I told you, we are having development on the IoT. So we would have these devices record the pressure and flow data, and they can be observed and monitored remotely by doctors and by nurses. So we have included those, and we also plan to include a online device monitoring system, so we can have reports on how the device is functioning as in real time remotely, so we can check those. Okay, any more questions, maybe perhaps? Okay. Okay, if there are no more questions, thank you very much. Again, we would welcome anybody who contacts us for collaboration or for research on development of these devices or other devices or even components. We are very open, and thank you very much for your attention. Bye-bye.
Okay, thank you, Mr. Adhika. With spirit and motivation, YPTI hope to be able to contribute to development of national industry, which has global competitiveness in the manufacturing industry in the future. Thank you. See you in the future. Yes, okay.